Right then, folks, next up, we got a tension, we need a tensile strain, so we're trying to stretch it. Tensile means stretching as opposed to compressive. One force up, one force down, easy peasy. These questions like this, money for jam, you just got to learn these definitions, really. Tensile stress, force acting per unit cross-sectional area. Tensile strain, extension per unit original length. Elastic limit, the point beyond which a material displays plastic behavior. Bam, easy peasy. Now this is a bit more of a beast. So I'll talk you through how to do this one. It tells us that we got a total thrust of 4.5 times 10 to the 6 newtons when our rocket fires. It's held in place, the shuttle is held to the launch pad by 8 steel bolts that are each of 9 centimeters diameters. They're pretty big old bolts basically. Now what we need to do is calculate the strain. That's the extension for each bolt during the test. So it's in a way it's handy because it doesn't really tell you very much. You can only use what you've got so far. So it gives us a force and it gives us a diameter. That's basically going to help us to get a stress. So let's try and find out what that is. So the force of course on each bolt will be the total force divided by 8, because we can assume it's been divided by the 8 bolts evenly. That gives us the force per bolt. The area of each bolt, of course, area is pi r squared, so it's pi times by 9 times 10 to the minus 2 divided by 2 to get the radius, all squared, and that gives us this value here for the area. Once we've got force and area, we can divide force by area and we can get the stress. Okay, that comes out to 8.8 times 10 to the 7 pascals. We've now got stress, we've got a value for stress. Somewhere up here it tells us the Young modulus for steel. There you go, we've got the Young modulus, and we know that the Young modulus is stress over strain. Therefore strain should be stress divided by the Young modulus. So we take our value for stress, there it is, 8.8 times 10 to the 7. Divide it by the Young modulus that's been given to us in the data, and it comes out to 4.4 times 10 to the minus 4 meters. Now, for the next part, determine the minimum number of bolts used. And that gives you quite a bit of data here. So you've got the elastic limit at 2.5 times 10 to the 8 pascals, or the ultimate tensile stress at 5 times 10 to the 8 pascals. So you've got to decide, are you going to calculate the minimum number of bolts that will come out of it having been taken to the point of breaking but not quite to it, not quite past it, or the ones that have been stretched but haven't been deformed by it. And either way is fine, the mark scheme allows for either. Bottom line is, in each situation you do the same thing really. The stress is force over area. Therefore the area will be the force divided by the stress. So you know the force, okay, we know the total force for our rocket, that's 4.5 times 10 to the 6, and we'll divide it by the stress. Now if we're using the elastic limit, it would be 2.5 times 10 to the 8. If we're using the ultimate tensile stress, it would be 5 times 10 to the 8. Once we've got that, we calculate the minimum area of steel required to hold the rocket down, and again that will come out to 18.0 times 10 to the minus 3 or 9 times 10 to the minus 3, depending on which of these two values you're using. Then of course the number of bolts will be the area that we require divided by the area of a bolt. So this basically we divide through by the area of the bolt that we calculated on the last section, and for one of them it comes out 2.8 and the other one it comes out 1.4. Now you can't round down, you can't only round up, so this would mean if we are using them again, i.e. they're not going past their elastic limit and they're all going to be, you know, we can do it again and again, it will be 3 bolts. If we're doing it, well I suppose you could keep using it, I suppose, so they'll just be warped to their point, but if we're doing it to the ultimate tensile stress, then it would be 2 bolts. So one would be that they're not damaged, the other one would be they are damaged.